Now let's imagine that our angle is not plus 45 degrees of polarization, but we have almost horizontal polarization, just perhaps plus 2 degrees of horizontal polarization. So it's almost horizontal, but not quite, like just almost, but not quite. Yes, just 2 degrees of the horizontal polarization. When such a photon goes through the polarizing beam splitter, this polarization dictates it that it must go like 97% of the wave function goes here, and perhaps 3% of the wave function goes here. There's so much of horizontal component in it and so little of vertical component in it. So what changes in our analysis? We still have the horizontally polarized photon coming out, but probability with which it comes out has changed. The probability, now I will cheat a little bit, and in the further optional lecture we might talk about this, but let's say that the probability is related to the amount of wave function that goes through, and we say that we will have 97% of photon coming through and 3% of photon is lost. Actually what happens is that, and this is the essence of quantum mechanics, is that percentage of the wave function translates into a different percentage of probability if you have percentages close to 0 or 1, and we will have a photon coming out with even larger percentage, like 99%, and only 1% of photon being lost. This is also the crux of this experiment, but generally it is possible to understand it without even this law of cosine square probability. We could just say that 3% is lost and 97% goes through, and we have photon in horizontal polarization with 97% probability. Yes, that's what we get. Now in the next video we will try to chain this thing and see what happens and how it works.